Alright, this is assignment 1 for in question 128 for assignment 1 for COM 2560. I already have no machine logged in here into the DJ server. Then I just go to a terminal, open a new window. Now let's go into my folder, which is in the DD, the Windsor 2022 COM 2560. All my files here. Let's show my storage code for each file. Let's secure this first. The storage code for file for question 1. Open the file in read-only state. If it's unable to open file, it's unable to open file is an error. And calculate the size by using the LT function to find how much bytes in each text file. So let's compile and run it. So gtc-g uk-q1.c-o q1 compile. Now let's run it. /q1. The thing is you have an argument here of 1. That means we have to do /q1, which is what we're running, space, whatever the text file you want to execute for this program and for all later programs in this video. So for this, so let's actually create our own new text file right here. So let's do cat, whatever you want to call it. Let's do 2.txt. Sorry, I have to do cat right arrow 2.txt. Yeah, like whatever you want. Hello. My name is Mohammed Umar Khan. Control D. And now they're saving the text file. Now let's run the program /q1 with the text file 2.txt. 37. This is how much bytes the entire text file takes up. 37 bytes in the text file, which is accurate. Now let's do the second question. So now let's show the code for the second question, which is ukwriter.c. There's the code. It opens the file in the read only, creates the file if it's not there, and truncates it. If it cannot create the file, then it shows an error to enable to create a file. As you can see, when you create the file, it will be created as list2.txt, and then rewrite. And then over here we have a array char with 101 /space gm/t, which means tab, Buick tab 2010/n, which means new line, 102 /space 4 tab Lincoln tab 2005. And then we write this fd, the value of the open file, and we write whatever is in this array into that file list2.txt when we create it. We've attached the 44. So we have shown that. Now let's actually compile and run the code to gtc-g uk-writer.c-o. Let's call it q2/q2. Now, although it looks like they didn't do anything, it actually did, because then you do more list2.txt. You can see the content of the file have been created in the newly created file list2.txt. Now we're going to do the second question, or the third question rather. It's basically the same thing, but instead of we're using standard call instead of system calls. So there's the same thing, but instead of using system call like fd instead of an int is connected to file pointer and opening the list2.txt w. Now the same with fopen here in a standard call. If let's say we call this function first, we compile and ran this function first before the second question, the previous question, then it will still create this file of list2.txt. Then we printf this content into this file of list2.txt, 101 gm tab Buick tab 2010, new line 102 4 tab, Lincoln, tab, 2005, new line. So now let's actually compile and run the code to gtt-g uk writer q3 .d dash o, they call it q3 slash q3. Then I do more list to dot text. Obviously we won't know if it actually did create because it's the same thing. But yeah, it did work. Anyway, now let's move on to the fourth question. So cat ukq4.d. Here's the fourth question. What they say, we have to count the number of lines in the file using system call. So we first open the file and the read only state. If it's unable to open, it shows the error. And then we over here, we basically reading the file. So the FD, which is the value when you open the file, comma the buffer, which is what we want to store the stuff in, store the content of the file in. That's the buffer. And now how much do we want to store it? So the maximum length we can store it, which is 65K, or that above, which is 65K right here, as mentioned here. And we're gonna keep doing this. We're gonna keep reading line by line, char by character by character until it clears, until it's less than 0. That's when it exits the program. But while this is happening, we then check to each line, each character. Sorry, and if that character is a tab is /n, aka the new line, then we increment the counter on number of lines, and at the end we print how much lines are in the file. Now let's actually compile and run it. So gtd-d ukq4.d-o, call q4 /q4. Now also we want to also initializing when we're running the file, we also want to tell which file we want to open. So let's do the one that we did before, which is the one that we're creating for question 1, which is 2.text. As you can see, when we only have one line in the file, number of line in the file equals 1. Now let's do /q4 list 2.text, which we created from question 2 and 3. The number of line in file equals 2. So this question works. Now let's do the next question, question 5, which is again the same thing in question 4, but instead of system IO call, we're using standard calls. So let's do q5.c. And as you can see, there's the code, the same thing basically. Open the file, whatever we call it. If it's null, then we're unable to open the file. Otherwise, go to the end of the file, read to the end of the file, and then just basically go until the end of it. And if that character in the file reaches a new line, then the incrementer auto increases and then print the number of lines of the file at the end. So now let's actually run the code gtt-g ukq5.d-oq5 /q5. Oh, sorry, I have to also have to include the text file we want to open. So let's do 2.text. Number of line in file equals 1. Now when we do /q5, the list file, list2.text, number of line in file equals 2. So there we go, it works here. Now the next question, which is question 6 at ukq6.c. Open the file in the read and write state, and also the append state here. All the stuff here, then we read through if it's unable to open the file, it shows an error. Otherwise, we read the file, the FD open file, which is what we open. The stuff is what we want to contain all this information in the file into, and how much we want to contain the slash stuff, which is 65,000 here. And whatever happens, we're just writing whatever in the file onto our screen here. As one basically means we'll write to our main terminal screen and not the actual list, the actual file screen itself. Start with an SG. And then after that, it will prompt the message, what information would you like to append to a file? You can enter whatever you want to enter. It will take that information and then write that information into the file that we opened before, that we get. And then we do the same thing, if you go open, rebar and append state. The append here part doesn't really matter anymore, but I just kept it just in case. Show an error if we cannot open it. And over here, we basically just do the same thing we did before. Over here and over here. Just open the file again and show the new information that's on the screen after we appended to the information from before here. So now let's actually compile and run. So gtc dash wall ukqtix.c dash oqtix slash qtix. I'll see what file do you want to take in. Let's do ff, oh not ff, sorry, 2.text. Hello, my name is Mohammed Mokan. What information would you like to append to the file? Let's say university. Now, as you can see, now say over here, hello, my name is Mohammed Mokan, university. Now, we're going to run this thing again. Now, what happens if we do more? Like, over here, hello, my name is Mohammed Mokan, university. Now, what we say, 2560, or sorry, comp space 2560. University comp. It only takes the information from the first from whatever you enter before the space. So if you wanted this thing here, comp 2560, is the right comp underscore 2560, but that alone also will just bring the comp underscore 2560 into it. Let me just show you what I mean by that. qtix 2.text. We did, now what we did space 25. Let me show you before here. Comp underscore 2560. Those shows it in there. So it has to, so anything after a space will not be included in the file. So what happens is you do /qtix 2.text. What happens is you do space? Let's do 45. That will still be accounted because unless it's the actual character other than space, it will not be included. No, space is not included until there's an actual character like 4 over here. That's why 4 is included here. So this works. Now let's do the next question, which is you're doing the same thing as question 6, except instead of system call, we're using standard calls. Over here, we open the file here. If it's null, show an error. We go to the file until the end of the file and we print every single thing in the file. Then we open the file again with an appendage state. Where we like to input the file, take the information from the user, then we print that information that we got from the user into the new file. And then the A, instead of like showing right beside the file or any information really, it'll basically show the A means that whenever you write to a file, it'll be attached to the end of the file, append. And then we open the file once again, and then display the new information. So let's do this. gtc-g ukq7.c-oq7 /q7 with more. Bring in let's do list2.text now. What would you like to append to a file? Let's do Lamborghini, because why not? Now I show over here, Lamborghini. So yeah, basically the same thing as question did, but instead of system call, we're using standard IO calls. Now the last question. Chat ukqwave.c. Now this open file, creating this file holds text W+. Printf, basically printing whatever the information from buff1 over to this file. Now this ftick here basically means that we are basically translating or giving the data file in this by 100 bytes from the start to the beginning of the file, and then we do it again, printf %s, but to bring this information to the text file. So basically, in this file, there's gonna be this information here, and then 100 bytes worth of zeros, basically a hole in the middle, and then this information here. And now let's actually run the code. Compile and run gcc-g ukqa.d-o q8 /q8. There's a hole in the file. There's a bunch of ways to do this with separate the command for Lionhead, but then we already have a question. We already completed question 1, that shows the tag or how much bytes are in the file. Let's use that to show if there's actually 100 bytes translated off in this file of question 8. So let's do .q1, which is our question 1 file, and the name of the file that we created with question 8, whole.text 120. Now why 120? Now you can see here, if you go to cat, more whole1.txt. More whole.txt. Now all we see there's this A B C D E F G H I J, and then capital A B C D E F G H I J 10 10. That's about 20. But then we did an fdict that's off these two by 100 bytes. It gives it all. So basically 10 plus 100 plus 10. It makes it 120 bytes. Meaning there is 100 bytes of zeros, aka a whole of 100 bytes in the middle of this file. So there you go. There's question 1 to 8 for assignment 1 called 2560.